All righty, hey guys, running a little bit low on energy. This is Corey's confusing book reviews, where we talk about the various books that I'm reading or have read. And today's is Clean Architecture: A Craftsman's Guide to Software Structure and Design by Robert C. Martin. This is the third book in the Clean Code series. I think there's four now. I haven't read the fourth one, but this is the third one. It's the most recent. It's I don't know, like 2017 or something. Let's find out. 2018. 2018. I think he's got a new book that's getting ready to come out, but I haven't read it yet. But let's do the too long didn't watch or whatever. If you're not a programmer or whatever, you can just skip this one. This is very much all about software development and programming and stuff like that. So if that's not your cup of tea, then you can just skip this one. But if you are and whatever reason you too impatient to watch the rest, it's a good book. I would highly recommend it. I recommend just about everything by Robert C. Martin, and includes. I'll just go ahead and say the blurb because I've said it before. But if you haven't watched it, the guy talk, conference talks or whatever, just Google him. Robert C. Martin, Uncle Bob or whatever. He's an excellent conference speaker. He's a little eclectic. He rubs some people the wrong way, but I think he's probably one of the best in conference, best technical speakers in the industry. And his books are equally fantastic. But yeah, so that's the too long didn't read. I just want to do the skip up. This is what we have coming up next. We have Jordan Peterson's 12 Rules of Life and Pragmatic Program Refactoring. So these are two more programming books. There are older books than this one, as I said before in the first one. I think if you just read the Clean Code, I think up until now, I think mostly if you read the Clean Code series or whatever, you mostly have the key points of wisdom in the field as far as like code quality, professionalism, and design and stuff, like at a high conceptual level. It's kind of like productivity books or whatever. After you read half a dozen or so, you start seeing the same things being repeated over and over and over again. And like you can read an entire book and maybe you get one good idea after a while, if you're lucky. And some of the lower quality books, you don't get anything new. I think that's kind of the thing here, where like if you wanted to start out just learning about being better programmer, like from a high level conceptual level, like for code quality and professionalism and stuff like that, you can just read the clean Code series, and that's, I would say that's like 80% of the things that you would probably want to read on the topic. You can just survey it with just these books. But sometimes reiteration helps, so that's why I read a bunch of productivity books and I read a bunch of programming code quality and practice books, is because sometimes you just need to be reminded of things. And so anyway, this particular book, Clean Architecture, is all talking about not just code quality, but just like if I was to like, let's do the blurb on the back of the book before I really dig into the meat of it. Clean Architecture: Practical Software Architecture Solutions from the legendary Rob C. Martin, Uncle Bob. By applying universal rules of software architecture, you can dramatically improve developer productivity throughout the life of any software system. Now building upon the success of his best-selling books Clean Code and The Clean Coder, legendary software craftsman Robert C. Martin, Uncle Bob, reveals those rules and helps you apply them. I would be surprised if he was the one who wrote legendary software craftsmanship. That seems like something he would write tongue in cheek. But I don't think I've done the blurb. I think the last one actually had something over the bottom where you couldn't even read the bottom blurb, but it says Robert C. Martin has been a programmer since 1970 and acclaimed speaker at conferences worldwide. His books include The Clean Coder, Clean Code, Agile Software Development, and UML for Java Programmers. Martin is a founder of Uncle Bob Consulting LLC and co-founder with his son Micah Martin of the Clean Coders LLC, and he has served as editor-in-chief of the C++ Report, as the first chairman of the Agile Alliance, and is co-founder and leader of the Object Mentor Incorporated. So, if you don't know, he is very much involved in the early like Agile movement and stuff before, obviously he got taken over by fake Agile, but we won't get into fake Agile. But yes, and he's very much a proponent of like the TDD stuff and everything like that. So that came out of the Agile movement. I think those two go together. However much that one adheres to the two, they go together. I would think to some degree, but so he's very much of that vein, and very much of, I would say, the previous guard of like staunchly OO. I wouldn't describe him as a militantly OO, but it's very clear that at least the way he presents like a lot of his talks and everything is very much talking about OO, like all OO, all the time. And I think there's since then there's been like a bit of a sea change. People are, at least my generations of programmers, we don't see the value of OO being so militant OO, and that maybe we could start introducing more and more functional principles, which actually predates OO. So the pendulum has kind of swung back towards the functional side, so to speak, nowadays. But anyway, that's not a here or there. He's very much an OO type of OO and Agile and TDD and professionalism, and so that's all about Robert C. Martin, I would say. And I love hearing him talk. I love his books, and this is another great book in the series. If I was to try and summarize this book, now keep in mind, I think it's been probably probably close to 5 years. I don't know. It's been a while since I read this book. And he talks about a lot of like kind of design principles from an architectural standpoint. And if I think he wanted to sum up architecture, he may even say this directly in the book. I don't want to give the point like this is my idea. I definitely got this idea from somewhere. Is that architecture is mostly about where you draw the lines between your system implementations. So are you drawing this interface boundary is where you expose all the database operations. That's repository, basically the repository pattern, right? And then this pattern here is where we set up an interface for web APIs. Like this is our boundary for web APIs, and of course that's where it's where you get a REST API would be developed there. That's a natural sort of, because that's a natural boundary that already exists. But even without that, that boundary would need to be defined somewhere. And a lot of times these boundaries get defined somewhat arbitrarily based off of technologies. Like that was an example where you're translating business logic plumbing into JSON data, right, over HTTP, and that's a natural technology transformation or whatever. But sometimes I think React kind of talked about this at the beginning, where people really hated React, especially in the beginning, because you're mixing concerns. You're mixing your CSS and your HTML and your JavaScript, and you got to separate your concerns. And the key, and one of the key insights I would say from the React brought to web development was like, no, the concern is the component. The concern is the feature that is implemented in this component, and it's implemented with different technologies, including HTML, CSS, and JavaScript. It's all one thing. It all has to work together. So it just define it all in the same place instead of separate files and stuff like that, which was very much how things worked before with Angular and stuff. Because Angular, you have to every feature is a minimum of 3 files, right? You've got a CSS file, a JavaScript file, and then a template file, right? It was nonsense, right? Anyway, yeah, so that's I guess that's how I would sum up like most of it's talking about where you're drawing your interface boundaries is how you defining your architecture. And maybe it's a horizontal thing where you're separating layers, like the repository. That's like you're drawing, when you do like the repository pattern, you're drawing like a horizontal like boundary, like across, like the whole database is abstracted in this repository. But you don't have to do that. You could do these silos, right? Of, I don't even know of like this vertical like segments that could go all the way to some of your web development. You have like one tiny little component, like a little widget that is piped to one particular controller, and in that controller everything is implemented, like the database connection and everything, and it's all implemented like completely independently from every other feature. It's just this tiny little snippet, and it's all vertically integrated, right? And that's another way you could do it, right? You could segment, your software system is part of like horizontal segmentation. That's microservices, right? Microservices are horizontal segmentation, where you can deploy each one individually, and they can be updated individually, and rolled out individually, and it can be managed by completely different teams. It's just this tiny little microservice. That's the whole point, I guess. Microservices having this independent deployment, management, and everything, and then you get things like serverless frameworks that start trying to compose them all back together into one single system to try and manage it all. And then you're like, oh, well, we got some code we need to share, so let's come up with a layer system where we could package up this shared code and then you're reinventing the monolith through microservices, and you've completely lost the plot. So that's, I guess if we were summarizing the book here, I would say that's the key point is making sure you're conscious of where you're drawing the lines. It's not about saying, oh, we're doing onion architecture. Well, why are you doing onion architecture? The reason you're doing onion architecture or hexagonal architecture or any of that is that you're doing a horizontal system slicing, right? You're saying, okay, here's my ephemeral third-party connections are at the very outside of my system, and at the very end, and there's various plumbing in between, but at the very heart of it is my pure domain logic. My domain logic is written in my language is plain object or plain language, whatever. It's using vanilla JavaScript. It's not using React. It's using plain C#. It's not using ASP.NET. It's in Java it's called the plain Java object or whatever, right? There's no entity framework on my domain models or whatever. Like it's pure testable domain logic, and that's the center of your application. That's so like clean architecture or hexagonal or onion architecture. But that's just one way you can design it. You don't, that is not the right way to do it, right? It could be the right way to do it for your organization or for this specific project, but there's always context, right? And that's before you even start talking about, well, some architectures are easier to manage at varying levels of skill versus others, right? Because if you try to do MVC, the big example, I think everybody knows MVC, right? Anybody who has done any significant amount of quote unquote MVC web development has seen what it devolves into. Because without militant, progressive, enforcement of code quality, it devolves into a spaghetti mess because everybody does everything in the controllers, right? It requires manual, conscious code quality effort. The architecture is enforced by convention. It's not enforced by technology, right? This is probably getting a little bit too much in the weeds, but anybody who knows me knows that I love Hasura. Hasura is this like API thing that you just point it at a database and it generates a GraphQL. You can track tables and stuff like that and set permissions and stuff and everything, and it implements a GraphQL API for you. Now, you can just generate that code like with a regular .NET application. I'm sure there's generators you could do it in .NET or JavaScript or any other number of languages. You could just point at a database and it could generate controllers, even set up relationships and stuff like that. I'm sure there's very fancy tools for doing that stuff. The whole point why I like Hasura is that you can't muck with the internals of Hasura. It is a pure API implementation. I mean, you never have to worry about what's happening in this controller versus that controller. I never have to worry about, does this controller already exist? I don't have to go looking for a particular feature. Like, did somebody already implement a get users? But is it on the /get person or is it on /get users? Because we conflated the two. I never have to worry about that because there is literally only one definition across the whole API, right? There is just one way to query in GraphQL your object or whatever. If you've got a person query, there is just the query for persons. It doesn't, and you could nest them and compose them and everything else, but you never have to worry about duplicating functionality because it's namespace somewhere else. Where we do /admin works slightly, /admin/person works differently than /person, which maybe for good reasons, in the past, that was a great way to do it. But in GraphQL, it's just /persons, and then there's some permissions you set versus admin versus users. And you never have to worry about whether, this has been implemented or if this is, that's another thing with API use of like, we change the permissions on a controller. Is it going to break the front end? You never really know because it's not type safe, right? But with like a GraphQL API, you can generate a client that the client consumes, and if you change the API on the back end and you regenerate the front end client code, it's going to break, and you want it to break because you want to know when something has changed that's a breaking change. But anyway, I like it, Hasura, because you can't muck around in the internals of that logic, right? You're forced to think of your API as stateless, fundamentally. It's not something, you can't send a random email in the middle of your controller. You can't talk to this, you can't write to the database arbitrarily in addition to doing this other. You can't log this other random value to this other service in the middle of your controller. It's like literally your gets and your queries and your mutations are always pure. Basically, it's from like the plumbing standpoint, right? The mutation obviously has a result, but that's the result. It's explicit. It's not any other result but that mutation that you defined. It's not some other mutation in addition to that. It is just that one mutation. But anyway, and so that's another way you could think about how to manage architecture, is thinking about what components you're using in your architecture that force you into a pattern that cannot be ignored, right? I don't ever have to worry about, whenever I have a project with Hesser, I never have to worry about what's going on in controllers. I never have to worry about that kind of stuff. It's always, it's working exactly as the schema has defined it, exactly the way that you expect it. Anyway, that's a sales pitch for Hesser. But nobody knows what I'm talking about. Yes. Yeah, so Clean Architecture, I think, is a great book if you haven't read it, especially if you're a junior programmer or whatever. If you haven't read it, very much in the way of code quality and architecture and professionalism and stuff like that, definitely check out a Clean Architecture, and in general the Clean Code series by Robert C. Martin. Anyway, we'll stop it there. We got, I'm going to finish this today, guys. It's been sitting on my I've had a stack of books for like the last month or two, and we're going to get through it today. So I got 3 more to go. Anyway, I will catch you guys probably next week unless something else comes up. Anyway, see you guys. Bye.